Hello everyone, my name is Varun. Welcome to this detailed explanation of my credit risk modeling project. In this video, I will walk through every step of the project from importing libraries to performing EDA, handling imbalance, model building, hyperparameter tuning, and finally evaluating results. My aim is to academically explain every action I took in the notebook step by step, including why I did it, what mistakes happened, how I corrected them, and what I learned. The main objective of this video is to build a machine learning model that predicts loan status, whether a person will default or not, based on multiple features like age, job type, marital status, education, contact type, previously marketing campaign details, and so on. I started by importing all the required Python libraries that help in data loading, cleaning, visualization, preprocessing, and model training. These includes NumPy, Pandas, Matplotlib, Seaborn, Scikit-learn, and IMBlearn. Each library has a purpose. NumPy is for mathematical operations, Pandas is for data manipulation, Matplotlib and Seaborn is for data visualization. I used sklearn.model selection for train test split and grid search CV. sklearn.preprocessing is for standard scalar. IMB is used for SMOT for handling imbalanced data. Here we have sklearn classifiers, which are logistic regression, decision tree classifier, k-neighbors classifier, and random forest classifier. We used random forest classifier for feature selection, which I will show you later in the steps. Here sklearn.matrix. Here we used confusion matrix, accuracy score, precision score, recall score, ROC AUC score, and F1 score. I also turned off warnings to keep the output clean. Next, I loaded the CSV file loandetection.csv into the pandas data frame. I displayed all the columns using pd.set option so that no column gets hidden. I explained df.shape that shows rows and columns, df.info that shows data types and missing values, and df.columns and df.describe that summarizes numerical columns. The dataset contains 60 columns. Out of these, many are dummy variables 0 or 1 after one hot encoding. For example, job admin, job blue collar, job entrepreneur to the job unknown are job categories. Marital, divorced, marital, married, marital, single, marital unknown are marital status. These are the educational levels. These are the months of the last contacted, and these are the days of the week last contacted. These all are the one hot encoded dummy variables. The target variable is loan status label, where 0 means loan rejected and 1 means loan approved. Checking constant features. I checked if any column has only one unique value, meaning it contains same value for all rows. A feature like that doesn't provide any information for a model. So no constant value existed at the start. I checked for duplicate rows. There were 2417 duplicate entries. Duplicates reduces model accuracy, so I removed them using df.drop duplicates. After removal, the dataset reduces to 38,771. I checked for missing values using df.isNA.sum. The dataset has 0 missing values. The next is data visualization. I plotted histograms for age, campaign, PDAs, and previous. Histogram helps us understand the distribution of each variable. KDE adds a smooth curve over histogram to show densities. Next is box plots. Box plots help me spot outliers by showing median, quartiles and extreme values. I have plotted the box plots with my target variable loan status label against the age, campaign, pdays and previous. Here we can see all the outliers that are in these box plots. Next, I created grouped bar graphs for job, marital categories, education categories, housing, loan, contacts and P outcome categories with loan risk label. These graphs show how each category contributes to loan acceptance or rejection. The next is outlier detection and handling. As we can see, all the numerical columns that are age, campaign, pdays and previous have extreme outliers. Using IQR method, I detected outliers in column age, campaign, pdays and previous. I found that 457 outliers are in the age column, 2396 in campaign column, 1514 in pdays column and 5535 in previous columns. I removed all the rows containing any outliers in these 4 columns. After the removal, the dataset size reduced to 30,696 rows. Next is feature selection. I calculated correlation to see which feature relates with the target. Many columns had no correlation because they were dummy variables. Then I checked how many unique values each column had, which column becomes constant after outliers removal. After outlier removal, several columns became constants, only 0 or 1, so I removed all constant columns. Is imbalanced data handling. For that, I have displayed the value counts and the proportions, in which we can clearly see that the class imbalance was very high. 91% classes were 0 and only 9% were 1. The next is data split. I have splitted my data into independent and dependent variable, and then I used the train test split on that independent and dependent splitted data. I used standard scaler to scale all features. Scaling is especially important for algorithms like KNN and logistic regression. Then I used SMOT. SMOT creates synthetic samples for the minority class. After applying SMOT on the training data, both classes became equal, 22,248 each. Next, I trained a random forest classifier on the resampled data to find which features are most important. Top features included age, contact telephone, campaign, month May, July. Then I removed features with importance less than 0.005. Finally, 39 most important features remained. Then I copied all my train and test data in the final variables. Comparison. We have trained our first model, that is logistic regression. The results shows as accuracy is 0.896, precision is 0.39 and recall is 0.18, that is very low. Logistic regression failed to capture the minority class clearly. The next model we have trained is decision tree. The results are as follows: accuracy 0.871, precision 0.33, recall 0.35. Decision tree was better than logistic regression. And the results are as follows: the accuracy is 0.64, the recall is 0.54, and the precision is 0.12. KNN performed poorly overall. We have selected the model decision tree classifier. The next step is the parameter tuning. I tuned the decision tree using a parameter grid of 270 combinations. The best parameters found: criterion, entropy, max depth none, max features none, minimum sample split 2, and minimum samples leaf 2. The best cross validation accuracy was 91.25%. And the next is threshold adjustments. I have changed the classification threshold to 0.35 to increase recall. The new recall is 0.63 and the new precision is 0.12. Lower thresholds help capture more positive cases but reduces precision. Final model evaluation. Matrices with best models plus new threshold. Results as follow: accuracy is 0.55, precision is 0.12, recall 0.63, F1 score is 0.21, and ROC AUC is 0.59. The model has good recall but low precision. This is acceptable in credit risk prediction because detecting risky customers is more important than predicting safe ones. The next is model evaluation with the confusion matrix. I have plotted confusion matrix, the true negatives, true positives, false positives, and false negatives. The matrix shows how many loan approvals and rejections the model predicted correctly and wrongly. The next is project learnings and mistake handling. I have made mistakes and corrected them. Mistake number 1: running SMOT before splitting data, that I have avoided. Mistake number 2: using threshold of 0.5, caused low recall, fixed with threshold tuning. Mistake number 3: not removing constant features after outlier removal, detected and corrected. Mistake number 4: using scaled data for SMOT, avoided. SMOT applied before scaling. Mistake number 5: blindly relying on correlation, avoided since dummy variables don't correlate well. Mistake number 6: attempted dropping features based only on correlation, corrected by using feature importance. Finally, the conclusion. This project successfully demonstrates the entire pipeline of credit risk modeling, from cleaning to modeling to tuning. Although precision is low, recall is strong, making the model useful for identifying risky customers. Thank you for watching. This is my complete credit risk modeling project explanation.